The story of physics is, for the most part, a tale of ever-increasing confidence. For 300 years, physics was all about observing and measuring, finding out how stuff works. In the early 1600s, an Italian got the ball rolling by measuring and observing balls rolling. Galileo also timed pendulums and dropped different size objects off the Leaning Tower of Pisa to see what would happen. And despite upsetting the Pope, his ideas had apparently made God very cross, Galileo's work became the rock on which modern physics is founded. Later, free from angry popes, Isaac Newton moved things on by abandoning balls and embracing apples. Why, he wondered, did they always fall downwards, not sideways or up? By 1687, he had an answer. It was a force called gravity, which worked on balls and apples, and planets, holding them in nice predictable orbits around the sun. In the 1800s, James Clerk Maxwell cast his eye over more mysteries. He showed how electricity and magnetism are related and can be combined as one force, electromagnetism, and that light had electric and magnetic parts and travelled in waves like water. Physics was now on a roll. New discoveries built on earlier ones, and some even had practical uses. Newton's laws predicted the existence of Neptune. Maxwell's work gave us radio and TV, and there's nothing much more useful than that. Physicists, it seems, had mastered the universe. All that was left was to plug a few remaining holes. But by 1900, the holes were getting bigger. The latest discoveries didn't build on the old ones. Things like X-ray and radioactivity were just plain weird, and in a bad way. All was not well in the world of physics. Top scientist Lord Kelvin saw dark clouds hanging over the subject. Then, in 1905, a Swiss patent clerk started a full-on storm.
Einstein, go.
26-year-old Albert Einstein tore up the script. First, he claimed that light is a kind of wave, but also comes in packets or particles. In the same year, he published his famous equation, E equals mc squared. It says that mass and energy are equivalent. And if that wasn't shocking enough, he released the mind-blowing results of a thought experiment. So hold on to your heads. It starts with the assumption that the speed of light in a vacuum is constant. Now imagine that someone watches a spaceship flying very fast. What they would see is a ship's clocks running slower than their own watch. And the ship will actually shrink in size. But for the astronauts inside, all would be normal. Einstein said that time and space can change. They are relative depending on who's observing them. This is special relativity. Now, special it might have been, but it wasn't enough. Albert had only just started. Next, he showed how balls and apples weren't the only things subject to gravity. Light, time and space were also affected. Gravity slows down time and it warps space. The stronger it is, the more space is warped and the more light is bent. Einstein called this general relativity. His ideas shattered traditional physics. He'd opened a door onto the weird world of the quantum, where cats can both be alive and dead, where God plays dice and where everything is uncertain. His famous equation led to nuclear energy. Without special relativity, the Large Hadron Collider would be pointless. General relativity predicted both black holes and the Big Bang, an idea now endorsed by both church and science. Galileo would have been pleased. Well done, Albert.